Good morning, all. I am Rushali Chaudhary, lecturer, Praveen Patil Polytechnic. We are going to learn basic science chemistry, subject code 22102 for semester 1. It is applicable to the all branches. Hello. As we are already started chapter 3 engineering material, in that we are going to start with the lubricants earlier. What is the lubricant? A substance which reduces the friction between the moving surface or parts of a machine. It's called as a lubricant. Here we can observe that these are the machine. In any machine there are two parts continuously moving. So as there is a continuous movement, there is a friction, and that friction increases the liberation of heat, degradation of machine parts. So reducing it, we are going to apply the lubricant which is going to reduce the friction of machine parts. When we are choosing lubricant for the particular application, certain characteristics or the properties are satisfied by that lubricant. It should have enough viscosity and oiliness. It should have enough viscosity and oiliness. So it should retain on that surface. If it is a oiliness is present, then only it will remain on the surface. If the viscosity it is little bit thicker than water, then only it is going to remain on the surface. Just take your hands. If I take your palm and if you put water like a substance, water like material, it will easily flow. But if I put some amount of coconut oil, it will remain on your palm. So that is due to the oiliness and viscosity. It should have flash and fire point higher than the operating temperature of the machine. What is the flash and fire point? A temperature at which lubricant will catch a fire. So that should be a higher. If we use coconut oil as a lubricant for machinery, it is easily going to catch a fire. Therefore, coconut oil is not used as a lubricant for machinery where higher temperature is achieved. It should be a chemically inert. It should not cause any reaction with the metal. It should not come out of the surface under pressure. When the machine is moving, when machine is working, it should remain on the surface. It should not come out from the surface. It should not evaporate easily. Evaporate means it should not mix with the air easily. It should be stick on the surface. Then only lubrication and reducing friction is possible. It should leave low carbon residue. It should not produce any pollution. It should not form emulsion with water. If it will form emulsion with water, that is going to attract the impurities or the polluting particles. Due to that, friction is increases. It should have cloud and pour points lower than the operating temperature of the machine. Cloud point means the temperature at which the given lubricant become cloudy, hazy. That is called as a cloud point. And pour point means the temperature at which liquid lubricant stops moving. It get a freezes. That point is called as cloud point and pour point. So it should be lower than the working temperature. The volatility of the lubricating oil should be low. It should not be highly volatile. What is meaning of volatile? It should not mix with the air. It should not evaporate. It should remain on the surface. It should possess a higher corrosion resistance towards the oxidation and corrosion. It should not react with the air and it should not react with the metal. When we are studying Lubricants. We must understand what is the properties of lubricant. Earlier we learned that the cloud point should be a lower. What is meaning of that? A temperature at which the lubricating oil become cloudy in appearance. It is loses their transparency and become hazy. That is called as a cloud point. Here, did you observe two oils are there? In this is a transparent oil, means light is easily passed through it. We are able to see what is the behind it. But this is a hazy one, that is a cloudy one. So we are not able to see what is the behind this jar. The temperature at which the oil become cloudy or hazy, it is called as cloud point. Pour point. The lowest temperature at which lubricant oil becomes semi-solid and ceases to flow is called as pour point. Ceases to flow means stop flowing. Here, did you observe these are the test tube in that we have filled the lubricating oil. But when we are starting from the first one, lubricating oil is easily flowing. As we are going to make a more cooler, we are going to decrease the temperature. Oil is not flowing easily. It stops flowing. Here it is a completely freezes. Did you observe the coconut oil which we are using at home that become solidify in a winter season? That process is called as ceases to flow or the pour point. It is not possible to pour easily. So the lower temperature, the solidification of lubricating oil take place. They are not flow easily. That is called as pour point. It indicates the suitability of lubricant used in a cold condition. Good lubricating oil should have a lower pour point. Otherwise, what will happen if we use coconut oil which becomes solidify at a winter temperature, low temperature? If we use for that machinery, machine parts become jam. It stop moving due to the solidification of lubricant. Lubricant will become solidify and movement of machine parts will not take place easily. Viscosity. What is the viscosity? It is a property of fluid that determines its resistance to flow. Just observe these two examples. In this we are taking a water and a stirrer. Here we are taking a syrup. Consider any syrup we are using it. You can also consider the honey or you can consider the oil. In which glass we are easily able to move this stirrer? Obviously in a water. In honey it will require more energy for movement. That is due to the low viscosity. Water is having low viscosity, but honey, lubricating oil, coconut oil have a high viscosity. It indicates of flow ability of lubricating oil. The lower the viscosity, greater will be the ability to flow. It's called as viscosity. So lubricating oil should not have very high viscosity or the low viscosity. If it is a low viscosity, it will not remain on the surface. It is easily flow away. But if it is very high viscosity, it is become solidify or stick to the surface. Movement of machine will not take place. If the temperature increases, viscosity of the lubricating oil decreases and pressure increases, viscosity of lubricating oil increases. When we are choosing the good lubricating oil, their viscosity should not be changed with the temperature. Here also consider the coconut oil. When it is at a lower temperature, it becomes solidified. viscosity increases, it becomes very thick, but at a higher temperature it is flowing easily, it is like water like liquid, so viscosity is decreases. Ideally lubricating oil should not change their viscosity with the temperature. That process is called as viscosity index. The rate at which viscosity of lubricant changes with the temperature is called as viscosity index. Good lubricant should not change their viscosity with a temperature. You can observe here, this is the 0 degree, at 40 degree it is easily flowing, at 100 degree very high flow is observed. But this is not acceptable for the good lubricant. Higher the viscosity index, lesser the variation in viscosity with a change in temperature. Therefore, good lubricating oil should have a high viscosity index. Means over the high range of temperature, their viscosity should remain same. That is called as viscosity index. At low temperature also and higher temperature also, viscosity will remain same, then it is called as higher viscosity index. Silicon, polyglycol, ethers, diester, triester have a high viscosity index. Flash point. The flash point of a volatile material is the lowest temperature at which vapor of the material will ignite for a moment when the ignition source brought near to it. The lubricating oil should have flash point reasonably above the working temperature. This is the instrument which is used to determine flash point of a oil. What is the flash point? The temperature at which when we start burning a substance it gives a flame. If we take petrol, kerosene as it is, it will not catch a fire. But if I put a flame near the petrol and kerosene, it will instantly catch a fire because their flash point is lower. Just consider candle. When we are taking a candle and if we put a matchbox near it or the flame near it, it is going to instantly pick a flame? No. It will take 3-4 seconds to achieve that temperature and then after it is showing you flame, because for a wax flash point is higher, so easily flame will not catches. But if we take a LPG, the house purpose gas that we are using for making a food at your home, what will happen? Just one spark of lighter, it is catching a fire. So it is a very low flash point and fire point. The temperature at which lubricating oil give a flash in presence of flame, it's called as a flash point. Fire point. It is the lowest temperature at which lubricating oil gives off enough vapor that will ignite at least 5 seconds. It's called as fire point. Flash point, the flame should be less than 5 seconds. Fire point, it is more than 5 seconds. The temperature at which given oil can start firing or start igniting more than 5 seconds, it is called as fire point. How to test of flash and fire point, that we are going to perform in a laboratory experiment. This is the video we are going to see next time. Thank you for your attention. If you have any question you can ask me. Thank you so much.